Okay, welcome everyone and thanks for joining our webinar today. Topic is transforming data into future insight with the Minitab Predictive Analytic modules. I'm Nur Silawati. I'm the Technical Support Specialist at Bizit Systems. Bizit Systems are independent local and representation for Singapore, Malaysia and Batam, Indonesia. Hopefully in 1 hour session with me today, you're able to see how Minitab Predictive Analytic will help you to solve your problem. We have a few housekeeping notes before we begin. We have a Q&A session after the presentation. Please submit any question you have and we will try to our best to answer them. If have time, if no, we will answer afterwards by email. We recommend view this webinar on your laptop or PC for the best result. Please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. We record this webinar and upload to our our website www.bizit.com and our YouTube channel Minitab Malaysia and Singapore. So there's no problem if you miss anything or want to review afterwards. Okay, so Minitab was developed in 1972. So today, Minitab in market for 15 years. Minitab statistical software is a software package for statistical analysis. So variety of statistical tools are available in Minitab. This software will be powerful software since everyone can use whether you are statistician or non-statistician or data sciences or non-data sciences. So our flagship product is a Minitab statistical software and we have others 5 products as well. We have the Minitab Connect for the data transformation and the dashboard. And then we have the Suffolk predictive model for machine learning and predictive analytics. But some of the algorithm inside the SPM, Suffolk predictive module, now available in Minitab statistical software. So you will able to see some of this for today webinar. Okay, and then we have we call it, this one is the Minitab quality trainer. Is the online training for, and then consists of few models like statistical inference, regression, DOE, and then of course for the predictive analytics also have in the quality trainer. And then we have others. One is we call it Minitab Engage. Minitab Engage is for addition execution project, and then Minitab Workspace is for visualize a template like VSM, FMEA, and so on. But today we focus on our flagship product, Minitab statistical software with specific tools. It will be predictive analytic module. So if you interest further with the others product, please let we know. We can provide the demo on that. Okay, here is some of the tools are available in Minitab statistical software. For example, for quality, I think most of you coming from the quality side. So Minitab have something like measurement system analysis, control chart, capability analysis, acceptance sampling, and tolerance interval. So for the measurement system analysis, control chart, and capability analysis, we already conduct our webinar. If you miss on this topic, you're able to play back on our webinar in our YouTube channel. So I think I will paste the link for that webinar. Maybe after this, you can view, okay, for the MSA control chart and capability analysis. I'll paste to the chat box. Okay. Okay, so we also have something like reliability engineering, and we latest Minitab 21 has a new tools like regression, and then we also have data driven, or today we focus on this one. For the data driven decision is for something like modeling. So for looking for a regression, if let's say you're looking for regression, we already conduct the webinar for regression, but today we focus on we call it the card classification and regression tree, or specific for the tree-based learning. Okay. And then I think last month, if let's say you join our webinar, so we already conduct for the DOE. Okay, so for information, DOE in Minitab not only for analysis, you can create your data worksheet before you go for the analysis and interpret the result. And then we also have something like process validation, but just want to highlight here is not miscommunicate, not the only in sequence, okay? Not the, you can see the process design, you can see in the, but this will be all this available in step menu. So maybe from the measurement system analysis, you will be able to see on the step and go for the quality tools, and then we'll get the case study and so on, okay? And then with complete tools for analysis, so our customer coming from various of sector, include the manufacturing itself, academician, services, and so on. All the type of company, not the only multinational company, MNC or small enterprise company or SME, also fit to use this software if you're aim to be data-driven company. Okay, so our agenda today focus on predictive analytics. One of the important things we need to know is about the validation. This validation is to see how good our models, and we try to show how to run or use the tree-based method algorithm, starting for information, starting with the Minitab 19. Minitab adding new algorithm we call classification and regression tree, or we call CAT. For those already use the Minitab 19, you able to see the CAT. Okay, I will show how to get the CAT. If let's say you already use the Minitab 19 and above. Okay, if below, I cannot help you to see, you cannot see the predictive analytic, especially for the CAT. Okay. So maybe this card is can be alternative for us when we cannot fulfill all the assumption of regression to solve our problem. And Minitab enhance the model with advanced algorithm like random forest and tree net. Okay, and then random forest and tree net only available when you subscribe the predictive analytic module. But if let's say you want to see the card, okay, but when you want to see the card, with the basic subscription, you able to see the card. And then of course, after you subscribe the predictive analytic module, not only consists of random forest, you also have we call it the automated machine learning. So all these things will we see on this webinar today. So hopefully in 1 hour we can do it all this our agenda. Okay. So basically, predictive analytics is something like you combine the use of data and then with the statistical algorithm and machine learning technique for what? To predict the future outcome based on the observation data. So we come like, if let's say you have your historical data set, you already collect the historical data set, so you able to use the predictive analytic. So collection of the algorithm with the high accuracy that allow us to make the prediction for the better decision. So maybe in the predictive analytic, you are able to see what are the key driver influence students to for maintenance on a machine, something like one, or you want to find what are the root cause of defect in my process. So for which potential customer are most likely to respond to our credit card or offer something that one. So it will help you for this kind of the answer all this kind of the question. So let we see more on this predictive analytic. Okay, so of course, predictive analytic is something like DMSA stages. So for the predictive analytic, we have a workflow. It consists of the 7 steps. The first step is, of course, we need to define our business problem. Let's say you have your objective, something that one. After you have your objective, you need to gather your data set. So maybe just simple one, if let's say you want to see about to predict the house price in your area, so maybe you can go for the income, you can go for the something like that one is something from the city or center of the city, or something like rural, urban, something like one. So you want to gather all the data set, and after that you can explore and prepare the data set. So I think we are coming from the manufacturing. You are already exposed with the something like control chart, something like visualization, something like its capability analysis is something good to you to prepare, and then to know your process is okay or not okay, stable or not stable, control or not control, before you go further for create the models. So something related with this visualization, maybe you can go for the scatter plot to see the relationship between your input variables versus your output variables. So for the create the model, so I will show after this the available algorithm you're able to see in the Minitab. And after you create the model, you can access the model, or you can compare model A, model B, model C, and so on. So from there, maybe during the access the model, the common we use this is the R squared. If let's say highest R squared, it will be good. It will be a good prediction model. And then after that, will you use that model to get the value of prediction, and then from there you can create the decision based on that, based on your model and based your prediction value. So all these things is not happen yet. It will be happen. So if let's say you want to see something in the future, so maybe predictive analytics will be the best tool to answer all that. Okay. And then here, I will success story about the predictive analytic from our customer. So I will share the link in the chat box to further story about this predictive analytic. Okay. So maybe from here you can see, is it they have related with you, or maybe have a something idea after this, okay, to see how they implement the predictive analytic and how they use and how predictive analytic help them. Okay. So before we go further, the first thing is that we call it validation. Okay, this one is the most important thing, and then this validation might be different between the traditional approach. Okay, so validation is something like you split your data into 2 groups. The first group, you create the models, and then the second group, you will test our model. So something like you have 100 data set. So maybe you split to 50 be the training data set, another 50 be the test data set. But split how many go for the test data set, training data set, test data set, it will depends on the type of validation. Okay, so why we need have validation? Because we want to prevent our model, it's something like overfitting. Okay, so before this, our expert say that if let's say the common issue regarding the modeling is something like overfitting, where if your new data coming, it not so fit with this model. So to avoid this, they come out with the validation. So commonly type of the validation in the market right now, we have the live and out cross validation. I think this one is a more approach to the traditional way. And then we have a K full cross validation. And then we have the validation with a test set. So all this one is a depends on the data set. So we recommend, okay, if let's say you have a smaller data set, will you go for the leave one out cross validation? This one out cross validation, something like you have 100 data set, you use 99 we are training, and then one is we are testing. And then the K full cross validation, you have 100 data set, and then you divide by 10 full, 10 group. And then 9 group be are the training, 1 group be are the testing. So it will depend how many full you want to divide your data set. And then the validation with the test set, it will be goes for something like 20% be are the tested data, 80% be are the training data set. It will depend, but all this is a depends on your data set. But in Minitab, we have a default setting. If let's say your data set less than 5K observation is a column, so the default setting for that is a K full cross validation. If let's say your K, your observation number, your column number more than 5K, so will be a validation with the test set. This one is it will depends on your preference. Okay. And then, of course, this one is all algorithm are available currently in Minitab statistical software. So we try split them into the 2 group, which is we call it supervised learning and unsupervised learning. So for the supervised learning, actually they split into 2 groups. It's a classification algorithm, a regression algorithm. Classification algorithm means that it's something like your response is not your text or classified or binary or multi-binary, is accept, reject, yes or no, something like low, medium, high. So it will be considered that classification algorithm. Inside this group, they have an algorithm like LDA, we have logistic regression, and then today we won't focus on the cut classification tree, and then random forest and tree net. Of course, for the regression here, regression is referred to numeric or measurement. So if let's say you have a one input only, so goes for the simple regression. If let's say you have more than 2, maybe you can go for the multiple regression, or in Minitab we call it the fit regression, and then so on. So for the unsupervised learning is something like you just only want to group your data set, not you don't have any output reference, but you just only have to want to group them. So we have also something like algorithm like clustering algorithm, and then the data reduction, we call it the principal component analysis. So all this is available in Minitab statistical software. Okay, but some of the experts always use both of this group. Before you go for the supervised learning, maybe you try group them into the using the unsupervised. After that, you back to the supervised learning. So it will depends. Supervised, it will be best rather than unsupervised. No, maybe unsupervised can be data manipulation or data features for you to before you go for the supervised learning. Okay, I think I will open the Minitab first to see where is your how you get the predictive analytic, or how to get the multivariate. So you can go for the step all this thing in the Minitab, and then we'll go for the multivariate. So if let's say you want to look on discriminant analysis, you go for the discriminant analysis. If let's say you want to see the unsupervised, you go for the simple PCA, principal component analysis, factor analysis, and then you have a cluster here. And then, of course, for the regression, we cover for the fitted, we have cover for the regression, more than one input. And then we have the binary logistic regression, we have ordinary, we have a nominal logistic. And then, of course, we have the predictive analytic. But predictive analytic in the standard subscription, you will be able to see on cut classification and cut regression. But once you subscribe for to others predictive analytic model, so where is you need have additional cost on this, so you will able to see automated machine learning, cut classification, tree-net, random forest, and then tree-net and random forest. So all this is available when you subscribe additional model for predictive analytic model. But no worries, today you can use the basic one with try with the predictive analytic with the classification. Just now I mentioned this predictive analytic available for Minitab 19 and above. So how to check it? You can go for the hub about the Minitab, and then you see what type of the production you have. If let's say it's 19, but still not available for the predictive analytic, maybe you need to update the version so you're able to see the predictive analytic. Okay, so all the algorithm are available in Minitab statistical software. Okay. So today we go try with the simple tree. Okay, this one is the objective of this predictive analysis. It will same with the regression. If let's say you join our webinar maybe last 4 months before this, okay, so we already conduct for predictive analytic using the regression. So today we do the same predictive analytic, but we focus on the tree-based method. What is it means by the tree-based method? Tree-based is the algorithm utilize a series of if-then rules to predict, to create a prediction from one or more prediction tree. So will be empower predictive analytic with not only speed to answer, but provide the accuracy and easy to interpret. For me, I think it's easy of interpreting. Okay, and then compared to regression, a tree-based machine learning algorithm provide deeper. Okay, this one is a good one. It's a map non-linear relationship. So I think if let's say we go for the real study, okay, you already faced with the one. I think is more problem is regarding non-linear relationship, not the straight line as I show in the webinar maybe. And then we have a visualization, and then we can handle, okay, predictive analytic can handle large data set. And then of course this one is a good one. If let's say you have messy data set, okay, so something messy here refer to missing value, a lot of missing value, a lot of outliers, maybe regression is difficult to handle it. It can, okay, regression is the best algorithm also, but maybe he lot of some time, or maybe he lot of information or technical part to do, okay, to proceed. So if let's say you have a kind of this criteria of your data right now, maybe you can able to use the cut or tree-based method. So let's we see this one. Okay, so this one is first we go for the cut. Cut is a classification and regression tree, and then of course we go for the random forest and then tree-net. So based on this view, you can see that cut only one tree. Okay, just only one. But random forest, you can see that more tree. Also for the tree-net. So we go after this. What happened for this? Why they have a multiple tree? Why we need have multiple tree? So we focus on the cut first. Okay. So for information, cut is developed by Freeman and Awesome and Stone in 1984. So they will works like you split the response, your Y variable into two partition based on the predictor setting. So cut will able to be a classification tree and then a regression tree. So cut will be run for both sides of the output. Okay, so this one is a unit to look on your output. So if let's say your output is classification, so you go for the classification tree. If let's say your output your response is a numeric, you can go for the regression. The visualization is the same, but it will different in term statistical. So if let's say you go for the classification tree, you're able to see the percentage, okay, represent the percentage or count something like one. But if let's say you go for the regression tree, you will be see the mean, standard deviation, and so on. So the different statistical measurement, but it will be same how to interpreting result. Okay, so same, CAT is no model assumption, no need to check the assumption because CAT is not the statistical modeling. Okay, it's a machine learning. So model follows the data and then easy to interpret. And then of course, you can go for the medium to large data set. Okay. So we go for the how to interpret, how to use the CAT. Okay, first you need to know your, we call it the root nodes. Okay, the root nodes, and then we build the block, or we call it the decision tree. Okay, and then, or we call it the nodes for this one. The first one is we call it the root node. Root node is the top node at the top of the tree, and then we have a, we call it, this one is a splitter. So splitter is we refer to the our predictor or our X or our input. And then of course, for this case, we have a two splitter. It's a weight less than 396.5, and then when weight more than 396.5, they split into this section. After that, they split again for the speed less than 16. And then other thing is, we call it here terminal node. It will something important to you. Terminal node is just something like a node has no sub branch. So meaning to say that terminal node is no splitting, not split. So it stop here. So we consider this one is the terminal node. So for this CAT, for this tree, we have a 3 terminal node. So no worries in this. I'll put the already mentioned terminal node 1, terminal node 2, terminal node 3. This one important because in the terminal nodes, you will able to see the prediction value. So for this case, we look on the mean of the terminal node itself. So the first thing you need to know what is the nodes, what is the root node, and then what is the splitter, and then the terminal node. So I think if let's say you go for the how to find the best setting, okay, so you can go for the splitter. So this value, it might be important to you, okay, for your parameter setting, to find the parameter setting, okay. So how to interpret? So something like that one. So if let's say you go for the terminal node 1, terminal node 1 is something like if your weight less than 396.5, then predictive value of manufacturing cost is 79.02. Okay, something like this happen, something like that one is our Y is the manufacturing cost, and then the input variables is the weight and then the speed. Okay, so in the weight and the speed, we have a variety of the value. Okay, so based on the CAT, they will come out with the weight to group them to weight less than or equal to 396.5, and then the manufacturing cost will be 79. And after that, they split to, if let's say weight more than 1, they go for this side, and then they split again, and then they will get the terminal node 2. So this one is the for decision rows 2. Okay, and then next one is the decision row 3. So this one is how you can get the outcome from the CAT itself. I think it's a good one if let's say you go for this group. So you want to find, okay, when our weight, it will be this setting, what happened to our manufacturing cost? So something like that one. So you can go one by one. So if let's say you have more terminal node, so we call it the big tree. So you have more decision rows for this case to study about your process or about your data set. Okay. So of course, we have example here. So this one example is a researcher want to use the data from the injection molding process to study the setting for machine that maximize one type of strength of a plastic pipe. So the variables include control on the machine, different plastic formula, and then the injection molding machine. So for your information, this is input. We have a 20 column for the input, and then we have one response here. Response here is will be strength of the plastic part. So the predictor like machine, formula, injection temperature, cooling temperature, and so on. So C here is continuous, and then T here is the text data. So will be give you some if let's say you have a mixed data type, you able to use the predictive analytic. So no worries. So you can mix together with the input variables. Okay, go for the response or the target variables. I think we look on this data set, easy to see it. Okay, so this one is the injection process. So how to see how many variables? Of course, maybe you save your data set in the Excel file. So you can go for the right click and then you choose the worksheet information. So in this worksheet information, they will give you something like, okay, column C2 is the text data set. If let's say T here is the C, consider that T is a text data set. So this column, only this column will be a text data set. The rest is the continuous data set. And then maybe you can check by yourself, is it the number or not? So it will be the number set. And then it will give you the counts or number observation for this, all this. And then maybe if let's say you have a missing value, will be shown on this one. But for this case, we have 1408 data set. Maybe it will big and then maybe we'll use the predictive analytic to you. So I will start with the go for the stat. Okay, go for the stat. We try. Okay, so our strength is will be response. The rest of this variable will be our predictor. So how to get the cut? So you go for the stat predictive analytic for the classification. For the regression, since our strength. Okay, since our strength is the variables. Okay, is the measurement. Okay, so we go for the stat, we go for the predictive analytic, we go for the regression. Okay, so for this case, we go for the strength. Okay, and then continuous, all this is continuous, only one categorical. So you go for the categorical. And then, of course, you can go for the validation. So just now I showed that if let's say less than 5K, Minitab will default setting by the K for full cross deviation. But if let's say you know C is a good one, so maybe you can choose to others validation. But I just proceed with the default setting. Click OK, and then maybe you can go for the option. So this one is the option. So this one is a parameter you will consider. Just I go for the default setting and click OK. So now you will see the cut. Okay, so this one is after output appear in the output pane, you can see that 37. So mean to say that 37 terminal node you have. Okay, you have a 37 group or 37 rows from this data set. Okay, so how to look that? You can see this one. Maybe you can go for the select alternative 3. Okay, so I click the select alternative 3. So the one is something like this one. And then from here, you can see that you have a 37 terminal nodes for, and then you have the important predictor is 21. Okay, and then your minimum nodes this one. And then of course, one look on the R squared. So based on this test R squared, is the quite higher, is the 0.8. It will acceptable. Okay, so for this case, so maybe you can go one by one for this case. Maybe you can go for the first terminal node. So in this first terminal node, we'll see that the predictive or value or mean strength of this terminal node is 283. Okay, with combination from the mold temperature less than this one, machine, and then the mold this one. Maybe I could go for this one, easy for you to see. Okay, this one is not just how to interpret. Okay, so we'll see that this one is terminal node 1, this one is terminal 2. But the optimum tree, okay, for a cat, just a cat with that default setting, they will show you is the best tree have a 37 terminal nodes. So in this 37 terminal node, maybe you want to find the maximize of the strength. Okay, so you can go for the highest mean, 5 nodes highest mean. So on this one, maybe you can go look on this 5 node highest mean. So you can directly what objective you want to find out. Okay, so for this case, we try with the highest value of the strength. So for this case, we go for the terminal node 3. So terminal node 3 is coming from this modeling temperature with this setting. For the mission, this setting, injection, pressure, this setting, and so on. So you will see how they come out with this group. Okay, the split by this group. So the one is one output you will be see in the card. And then another thing is an interesting part is, of course, you want to see which one, okay, which predictor it will most important into the strength. Okay, so for this case, we go further. We call it the relative variables important. Okay, for this case, we have the mole temperature. It will be the best predictor. Okay, it will be best predictor. The rest, maybe you can go for this R square and so on. So if let's say you're satisfied with this one, okay, maybe you have the new data set, you can go for the scatter plot, you can go for the residual plot. Maybe you satisfied with this one, and then you can go for the predict. If let's say you have a new data set coming for this account. Okay, so this one is how you can use CAD to solve your problem. I think that one is the best part is this lah. Okay, for the regression, for the terminal node, you can group them into this group and then try find out the why it happened, is coming from where. Okay, so all this is something like Minitab will suggestion to you. But no worries, if let's say you're not satisfied with this one, you have alternative tree. Maybe you want to have simple tree. Okay, you go for the simple tree, but you lost on this R squared. Okay, well, this simple tree, you lost the R squared. So of course, if let's say you go for the 5 optimal tree, maybe you can go for the lowest mean, something that one. Or you don't want to use this one, maybe you can go just pick only. Okay, so you just want to see on this one. Okay, the splitting parameter for this case. So in this card, actually they will ask you, they will provide you how to use this, okay, the parameter setting, and then what will be the best predictor. Maybe go for the mole temperature and go for the mission and so on. But this one is so far our customer always say that how many variables we need to consider be the best. It all depends. Okay, doesn't so far does not have any time of row to find out where. But just like, okay, injection pressure maybe 5 times more important rather mole temperature. Okay, something that when you can compare the predictor based on this relative variables important value. Okay. Okay, so I hopefully you clear how to run and then how to interpret the card. Okay, so go for the start, go for the predictive analytic, go for regression. Why regression? Because our output is the number rate. Okay, so we have a two-way lah. Whether if let's say after this you subtract the analytic module, you can go for the predictive, you can go for the card regression. Okay, the result is always the same. Okay, the result will be the same. Okay, just different menu only. Okay, so I think I proceed with this one. Okay, already put this one. Okay. Okay, so I think if let's say I'm the customer also, in my mind, why we need to have others algorithm since CAD already can solve our problem. So just now I mentioned that CAD only rely on one tree. Okay, one tree. So as we know, only a simple less data set is not so good, but so you need to come up with the more data set. Okay, something that one is something simple analogy why we need have this algorithm like random forest and tree net. So to tackle that, okay, we believe that more tree is more reliable rather than one tree. So that's why they come out with the others algorithm. We call it is a random forest and then tree net. Okay, based on this equation also something like your y equal to fx plus error. So something like complexity, and then we want to balance between the bias and then the variance. Okay, but to be a multiple tree, we have some kind of the method. We call it, this one is a baking method, refer for the random forest to, and then we have a boosting method for the tree net. So they will be a different method to come out with the multiple tree. Okay, not the have a something like same method. It will different method. So in mind now, it's not so okay to compare each other. Okay, because they come out with the different method to give you multiple tree. Okay, are we show for this case? Okay, I will go for the random forest first. Okay, so random forest basically they will use the bootstrap sampling where sample with the replacement. For example, okay, we have 100 data set. They come out with the 10. They collect the 10, and then after that they build the model, build the cut, and then they will pull back to the original one, and then they come up with another trial, and then they come up with the new tree. Okay, new tree from the bootstrap 2. Okay, and then bootstrap 3, and so on until how many data set you have, and then they combine together, and then they come out with the, if let's say classification, they go for the majority rows, and then if let's say regression, they will go for the average rows. So this one is how they come out with the multiple tree. Okay, to be from the single cut be other multiple tree using the bootstrapping. Okay, so for this case, actually for the random forest can be effectively used with the wide data set. Wide data set means that you have a many column rather than a row. Okay, row is an observation. So like that one. Okay, you have something like many, sorry, for this case, I go for this, many columns rather than observation number. It's a, we call it, this one is a wide data set. Okay, we'll suggest that. Okay, but you can try it. And then of course, we believe that random forest typically is more accurate than individual decision tree. It's the cut only because it's a multiple tree. Okay. Okay. So I will try. We will try with the same case study just now. Same case study just now. Okay, same case study. I will back to this case study. Okay, the same. But now we try using the using the random forest. Okay, go for the predictive analytic. You module. You go for the random forest regression. Okay, for the response here, the same. Go for the strength. Our continuous predictor is the mission, all these things, select all this, and then for the category, we have the formula, and then go same, and then you click OK. So now, okay, Minitab we run, the random forest, and then come out with this R squared, and then come out with the out of back. So based on this R squared is a 77.18. So our aim is a more 3 will be has the highest has higher rather than simple 3. So maybe it's not so good for the random forest. Maybe we need to have another advanced, okay, advanced model. So we call this one is the tree net. Okay, it's a tree net. It's a little different. Just now they using the boosting method. They using the boosting method. They're using the boosting method. So now Now they using the gradient boosting algorithm. Okay, that one is the algorithm that sequentially fit small tree, then use the error from the previous tree to create a new prediction and update the model. For example, here from the average residual we can get from the actual data with the predict data, and then you get the residual. So from the average that one, they come out with the 3. From the 3 residual, from the cut 1 residual, they come out with the another 3. And then another 3 and so on up to how many data set you have. Okay, so this one is a different between a random forest and the tree net. And then, of course, the tree nets, we believe that we provide the highest performance and then more complex for models that consist of several hundred small trees. And every tree contribute a small amount to the overall model. So basically for the tree net, I think it will best is they will give you something like, we call it the partial dependency plot, PDP. This one is something like you can see the changes of the key predictor or effect of your response value. Okay, so I will show for this TrueNet. So we go back to the Minitab. Okay, we go back to the Minitab. I will use the same case study here. I will use the same case study. So we go for the we go for the predictive analytic module. We go for the TreeNet regression. So I just fit the fit model. So for this case, our response is the response. Our strength, the same. I go for the machine. And then for this case, I go to for categorical formula, and then you click OK. Okay, so you will see the TreeNet result. Okay, so the TreeNet result, so we have the method, they will mention what the method you use, and then they have a R squared, and then they have a R squared here. So they will use the test here is more than 70%, and they will be accepted. This one is the highest rather than for random forest just now. Also in the TreeNet and random forest, they will provide you the relative variables important. So based on this one, the more temperature will be the good most important predictor for this case. Okay, so I will try to compare all this one. Okay, to compare all this one. This one. Okay, so this one is the TreeNet. Okay, this one is the cut. Okay, and then this one is the random forest. So for based on this all the algorithm, mole temperature is most important for this trend. Okay, so this one is how we use the predictive analytic. So maybe if let's say look on the after this you want to see accuracy. Okay, so you look on the R squared. Okay, so based on this R squared, the TreeNet, it will be the highest value of the R squared. But for the random forest, they will using the we call it out of bag. Okay, but the same parameter or same statistic is a R squared here. Okay, so this one is how will we use this one. But no worries, no need to go one by one. After you go for the in the Minitab predictive analytic module, we able to see, we call it the automated machine learning. So automation machine learning is they will automatically run all the available algorithm in for you, and then they will suggest will be the best algorithm to use after this. So that one is something like alternative opinion. Okay, if let's say you are the first time to do the predictive analytic, so they will run regression, they run the cut, they run random forest, and then they will run the TreeNet, and then they compare. If let's say regression, they compare the R squared, and then for the classification, they compare the ROC. So that one is the same Okay, so we go for the Minitab back. I will use only the same, okay, only the same data set. We use the same data set. So how to get the automated machine learning? Go for the predictive analytic module, go for the automated machine learning. So for this case, it's a continuous since the strength is the numeric. So for the continuous response, our response is the strength. Okay, the continuous is the all this one is continuous. Okay, for the category or for the formula, and you click OK. Okay, you click OK. Okay, you click OK. So it will take some time since they run all the algorithm available in Minitab. Okay, they will take some time for this case. Okay, and they will come up with the best algorithm for you. Okay. 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 Sorry. So for this, we include first. Okay. So now in this output, they will use the stepwise regression, tree net, random forest, cut, and then of course they come out with this. With this model selection. In this model selection, you can see the R square here. So tree net, it will be the highest R square. Okay, so mean to say that based on this data set, based on the automated machine learning, Minitab will suggest to you is the tree net algorithm. So no need go for the one by one algorithm. So maybe it will save your time to get the result for this case. Okay, so this a tree net, and then of course after they identify R square is the highest, it will be the best model. So they come out with the hyper. This one is the for the tree net. But no worries if let's say you don't want with this model, not satisfied with this, you can go for the select an alternative tree. Maybe you don't want, you want just go for the multiple regression. So you can go for the multiple regression and then choose the display the result. So they will see how they go regression and they will go off kitchen and so on. This is same with the step menu button. Okay. So the one is the will help you for the automated machine learning. So sometimes like second opinion to you. Okay. If let's say you are the new or maybe you are expert, also will we use this automated machine learning. Okay. So this one is the same R square and then look on the relative variables important. And then of course, if let's say you have a new data set coming, you satisfy with your model, so you can do the prediction. So for this case, I will try show for this. Okay, just simple thing. I have a new data set and I satisfied with this selection model from the Minitab suggestion. So I go below and then you see the predict button, all same with the regression or tree net or something like one. Okay, so you can see the predict here. So you can predict if let's say you have new coming. So for this case, I will go for this predict. Okay, so for this case, I go for the column. Okay, so this one is a machine, and then this one is an injection pressure. Okay, injection temperature, cooling, okay, temperature, melt temperature, and so on. So you can insert all this one, and then you click OK, and then you see you will able to see the fit distribution. So in this case, for this fit distribution, okay, so fit distribution here is we call it the predictive value. So will appear in the our worksheet, not the output pane, in the our worksheet. Okay, so you can see the fit value in the worksheet. Okay, so I think this one is the pros and cons for the cut, random forest, and then tree-net. This kind of the criteria information maybe it will help you how to choose which one is the best. Okay, but if let's say you ask me, I will suggest you start with the cut to find out or identify your group first, and then after that you can go for the advanced model like random forest and then tree-net. Okay. So if let's say you have a question, drop in the chat box. Okay, I will address. I think we are rushed in this one. Okay, maybe I will answer one of this maybe. Okay. Oh, this question is something like, okay, this predictive analytic model can be used to screen out significant predictors. So you can see this one based on the relative important factor. So just now I will show this one. Okay, you can see on this relative variables important. For this case, we're not able to show the p-value, but you can replace that with this relative variables important. Okay, but how many? I'll just explain it. We doesn't have any term of role. It will depends on you. Okay, how many up want to. So, but this one is the strength. Okay, 100 strength. So 100 here is consistent 100 confident. Okay, for this small temperature, it will more effect into the our strength. Something like one. Okay, hopefully answer your question. Okay. So for this case, what the acceptable are squared for this method? Same, okay? It's already same. Maybe 70% is our good, okay? It will good. Same with the regression, same, okay? For this case. I think I will answer this question also. How many related question to consider importance variables. So it will depends on you. For this case, maybe injection temperature is not more important. It consists only 10.6 rather than 56.8 and something like one. Okay. Okay. This question. Okay. Okay, so the same question is any guideline for the RSCAD. So we go for the basic we always use is 70% is very good model. We consider that. Okay, this session it will record. No worries, this session it will be recorded and then we upload into our YouTube channel. Okay, so I think this okay. Okay, this one is a good one. How to interpret the card classification result? It always same. Okay, I will go for the group. Okay, for the Minitab, I will go back to the Minitab. Okay, so in the card classification, it always something like you have a percentage. Okay, you have percentage here. Sorry for this case, I try with the simple one. Okay, you have percentage. You come up with the percentage, not the mean or standard deviation. I think I will go back to this and then back to the R squared. Okay. So that's something that one. Okay. Sorry, sorry. This picture is not so big, but this kind of the measurement or statistical you can get from the classification tree. It go for the percentage. Okay, how many percent inspect or expect. This one is depends on your how many. Do you be a classification only two or only two consist of two binary, or maybe you have a multiple, so you can get a multiple for this case, and they come out with the count and then percentage for this case. Okay, it will different on the counts and then mean. Okay. Okay. I think the rest I will cover or email for you after this. Okay. The rest I will email after this. Okay. So we get back to the see. I think that we're rushing. Okay, sorry. The one is something like okay, so prawns and then this one. Okay, this one. Okay, so this it will best to you. Okay, you can get yourself a 2 days training when you purchase the predictive analytic module. So otherwise, you can also attend the training at cost. For Malaysia customer, this training is a HRDF claimable. So for more information, please check on this link. Okay, or scan the QR code here, and then I will paste the link into the chat box to get more details on this, because in my presentation today just give you the overview how to get how the hyper how to your option, something like what is the method, least square method, and so on. So that one will cover on this training. Okay, we are consist the 2 days training to cover all this. Okay, something like you can see in this one, you can see on this one, you can see on this. Okay, you can see that we include the discriminant analysis, we include the test set, what is the K-food validation, okay, something that one, you can get the more details on the card, regression, maybe card classification and so on. So they're more comprehensive rather than this two-day webinar. The today I just show how to run, how to get the idea from this data set, something that only one case study I will use. Maybe you go for our training, you can see multiple or different variety of the case study or data set you will use. Maybe have a similar with your problem now or something like one. So if let's say you want to further, you can scan your barcode here for Singapore and Malaysia. It's a little different, but the content is the same. Okay, the content is the same. Okay, so I think that one is the thank you for your time and attention. So to learn more about Minitab, please contact us by visit our website www.minitab.com or www.bizit.com or email to us to minitab@bizit. And then to get some tips or trick in our Minitab product, please follow us through media social like Facebook and link at Minitab Malaysia and Singapore. And then to access back our previous webinar, please subscribe to our YouTube channel, Minitab Malaysia. And I really appreciate if you fill out our survey in order to enhance our webinar session. So maybe see you next time with different topic and happy learning.